Welcome to my YouTube channel. Here I have a short and brief video lesson on arithmetic progression. In this video I will show you the past examination paper regarding the arithmetic progression, so stay with me. So before proceeding to the problem solving, I will tell you here the definition of arithmetic progression, and I will show you two formulas regarding the arithmetic sequence. So an arithmetic sequence is a sequence having this kind of characteristics. As if the difference between the consecutive terms is constant, then that sequence is called an arithmetic sequence. For example, if we have a certain patterns of numbers, say A1, A2, A3, and so on, okay, this patterns of number is called an arithmetic sequence. This is called an arithmetic sequence if the difference between the consecutive terms is constant. A2 minus A1 must be the same as A3 minus A2, A4 minus A3, A4 minus A3, and so on. So this difference is called common difference. So shortly, a sequence is said to be an arithmetic sequence if the difference between the consecutive terms is constant. So to make things clear, let me give you some patterns. Look at this sequence: 3, 7, 11, 15, and so on. If you see the patterns of this number, the difference between the consecutive terms is constant. Between 3 and 7, between 7 and 11, between 11 and 15, and so on, we do have a certain common difference. That common difference is 4. Therefore, this can be considered as an example of an arithmetic sequence. So the first formula that we have here is an is equals to A1 plus n minus 1 times d. This is the nth term formula for an arithmetic sequence. For example, if you see here, definitely the number that comes after 15 is 19, and so on. So in some cases, if you are asked the 10th term or the 12th term, you don't need to list out all the terms. For example, if I want to calculate the 10th term will be based on this formula. The 10th term will be the first term plus n means 10 minus 1 times the common difference. Okay, so the first term is already 3. This is the first term. 3 plus 10 minus 1 is 9, and the common difference is 4. So this will be 39. You see, without listing all the terms, we can answer any terms of this sequence. So the 10th term is 39. So similarly, we can calculate any terms of the arithmetic sequence. The other thing is, here I will tell you about the formula for the arithmetic progression or arithmetic sequence. Here, this is the formula for the sum of the arithmetic sequence. So let me take again the previous example: 3, 7, 11, 15, and so on. Obviously, this is an arithmetic sequence. So I told you that the 10th term is 39. But here, this formula can be used to calculate the sum of the first n terms. For example, if I want to know the sum of the first 10 terms, the sum of the first 10 terms means 3 plus 7 plus 11 plus 15, and so on, the next 6 terms. We can use this formula. The sum of the first 10 terms is equals to 10 over 2 into 2 times the first term plus 10 minus 1 times the common difference. Okay, I used this this sequence. So for this sequence, you will get 5 into 6 plus, this is 9. 9 times 4 is 36. So this is 5 times 42. The result is 210. So the sum of the first 10 terms in this sequence, the sum of the first 10 terms is 210. Which of the following is an arithmetic sequence? So here we are asked to determine which of this given alternative is an arithmetic sequence. So if we see the choice A, in choice A we have the numbers 3, 5, 7, 9, 11, and so on. You see, if you check the difference between the consecutive terms, it's 2. There is a common difference, which is 2. Therefore, this is an arithmetic sequence. A can be an immediate answer. Let's check for B. In B, we have 3, 6, 12, 24, 48, and so on. You see, the difference between the first and the second is 3. Between the second and third is 6. Between the third and fourth is 12. There is no common difference. No common difference, right? No common difference. So B cannot be an arithmetic sequence. We can also check that the remaining cannot be an answer. Minus 3, comma 6, comma minus 9, comma 12, minus 15, and so on. Look at the difference between the first and the second. Here, take the difference, it is 9. The difference between here is negative 15. The difference between the third and the fourth, 21, and so on. There is no common difference. No common difference. So C cannot be the answer. So this cannot be the answer. Now let's check for D. In D we have 1, 3, 6, 10, 15, and so on. So look at the difference between the consecutive terms. Here the difference is 2, 3, 4, 5. There is no common difference. There is no common difference. So D cannot be the answer. Therefore, our answer is A. Which of the following relation holds for the given sequence? The sequence is minus 10, minus 3, 4, 11, and so on. This is our sequence. Now let's check for the difference. The difference between the first and the second is positive 7. Between the second and the third is positive 7. The same thing between the third and the fourth. So there is a common difference, which is 7. Okay. So this is an arithmetic sequence. So we can write the second term is the first term plus the common difference, right? That means the second term, or minus 3, is the same as minus 10 plus 7. The third term is the sum of the second term plus the common difference. Okay, the second term is 3. The third term is 3 plus, minus 3. So the third term is minus 3 plus 7, which is 4. And the fourth term is the third term plus the common difference. The third term is 4. The common difference is 7, which is 11, and so on. Therefore, we can write the nth term as the sum of its preceding term plus the common difference. This is the general formula that we can have regarding this sequence. So the relation in B holds for this sequence. Let an is n plus cos n pi for n 1 up to infinity. Then which of the following is true? Now let's check for each of the alternative. The fifth term, say a5, is 5 plus cos 5 pi, because an is n plus cos n pi. So whenever we make n 5, here it becomes 5, here it becomes 5. Therefore the fifth term is 5 plus cos 5 pi, but cos 5 pi is a negative 1. Therefore the fifth term is positive 4. So A cannot be an answer. Let's check for B. A cannot be the answer. Let's check for the B case. The 10th term is 10 plus cos 10 pi, according to the given here representation of the sequence. So the 10th term is 10 plus cos 10 pi. This is 10 plus cos 10 pi is positive 1. Okay, you can refer back to the trigonometry. So this is 11. So still B cannot be the answer. Let's check for C. In C we have the 7th term plus the 8th term, but the 7th term is 7 plus cos 7 pi. The 8th term is 8 plus cos 8 pi, but cos 7 pi is minus 1, and cos 8 pi is positive 1. Therefore this is 6 plus 9, the result is 15. So C can be the correct alternative. Let's check for D. D says A7, the 7th term minus the 6th term, but the 7th term is 7 plus cos 7 pi, minus the 6th term is 6 plus cos 6 pi. So substitute here 7 plus the cos 7 pi is minus 1, and cos 6 pi is positive 1. So this is 6 minus 7, the result is minus 1. So still this is also wrong. Therefore our answer is C. What is the 50th term of the given sequence? We have this sequence. So for this sequence we are asked the 50th term. Look, the numbers are 3, 10, 17, 24, 31, and so on. So listing out all the terms will be very difficult and time taking, but we have a formula to determine the nth term of an arithmetic sequence. An is equals to a1 plus n minus 1 times d. Because this is an arithmetic sequence, the difference between the consecutive terms is 7. So our first term is 3, and the common difference is 7. So we can use this nth term formula to calculate the 50th term. So put n50. So the 50th term is equals to the first term plus 50 minus 1 times the common difference. So the first term is 3, 50 minus 1 is 49, and the common difference is 7. So this is 3 plus 49 times 7 is 343. So the result will be 346. So the 15th term in this sequence is 346. If an is an arithmetic sequence with the first term minus 5 and the fifth term is 15, then what is the 11th term? So we have here the first term which is minus 15. You can say small letter a or capital. In both cases we assume that they are an arithmetic. The fifth term is 15. So what will be the 11th term? We are asked the 11th term. So let us take the fifth term. The fifth term is the same as the first term plus 4 times the common difference, because the nth term is the sum of the first term plus n minus 1 times the common difference. Okay, so if this is the case, the fifth term, or 15, is equals to the first term plus 4 times the common difference. Now collecting like terms, 15 plus 5 is equals to 40. This is 20 is equals to 40. So dividing both sides by 4, d becomes 5. So now we can completely determine the 11th term. The 11th term is the first term plus 11 minus 1 times d, but the first term is minus 5 plus, this is 10 times the common difference, which is 5. So this is minus 5 plus 50, which is positive 45. So the 11th term is positive 45. A certain meeting hall has 20 rows of seats. Okay, there are 20 rows of seats in a certain meeting hall. The first row contains 22 seats. 20 seats in the first row. There are 20 seats in the first row and 22 seats in the second row. Okay, let me write it. 20 seats in the first row, 22 in the second, 24 in the third, and so on. Totally, there are 20 rows. Okay, in the first row, 20 seats, then 22, 24, and so on. We are asked how many seats are there in the 20s row. Okay, when we see the patterns of this number, there is a common difference between the consecutive seats, number of rows. So you can assume the first row as A1, the second row as A2, the third row as A3. Okay, then according to this notation we are asked the 20th row. So we apply the nth term formula to calculate the number of seats in the 20th row. Okay, the number of seats in the 20th row can be calculated by using this formula. So A20 is equals to A1 plus 20 minus 1 times D. But here the first term is 20 and the common difference, the difference between the consecutive numbers here is 2. So substitute here the first term 20 plus, this is 19 times 2. So this is 20 plus 38. The result is 58. Therefore, there are 58 seats in the 20th row. Therefore, our answer will be B. The answer will be B. a business association gets a net profit of birr 3,000 at the end of each month. So here there is a certain business association who is earning 3,000 every month. Just after 5th year, the total amount of this business associate, the net or the total amount they have is 230,000 birr. So what was the amount of the business? So to know this business association is earning 3,000 every month means they are earning every year they are earning 12 times 3,000. Okay, every year they are earning 36,000 birr net profit. So at the end of the 5th year, the net profit will be 5 times 36,000, which is 180,000 birr. Okay, they get this much amount of birr by the end of the 5th year, but currently they have this much amount of birr, 230,000. So the initial amount should be the total amount that they have now minus the net profit they earn in these 5 years. So the net amount should be 50,000 birr. Initially they had this much amount of birr. This is the required answer. If an is an arithmetic sequence with first term 5 and the 5th term 21, then the partial sum of the first 30 terms is how much? So to make this symbol clear, let me just write first the given. Given the first term is 5 and the 5th term is 21. So we are asked the sum of the first 30 terms of this sequence. Shortly we use this notation, S30 is how much. So we will apply the formula for the sum of the arithmetic sequence, which is given by Sn is equals to n over 2 into 2 times the first term plus n minus 1 times the common difference. This is the formula for the sum of the first n terms of an arithmetic sequence. But here we have the first term already. We need the the common difference. We get the common difference from the 5th term. Okay, here the 5th term is 21, but the 5th term is given by the first term plus 4 times the common difference. So this is 21 is equals to the first term plus 4 times the common difference. So this implies 21 minus 5 is equals to 40. So 16 is equals to 40. Dividing both sides by 4, we get d is equals to 4. So we substitute everything here. Therefore, the sum of the first 30 terms is equals to 30 over 2 into 2 times the first term plus 30 minus 1. Substitute 30 in place of n. Okay, so 30 minus 1 times the common difference. So this is 30 over 2. You can say it 15, but for me I prefer to write this thing 10 plus this is 29 times 4, which is 116. This is 30 over 2 times 126 by 2, it's 63. Now 63 times 30 will be the sum of the first 30 terms, or you can make it 630 times 3, which is 1890. So this is the sum of the first 30 terms of this arithmetic sequence. If an is a sequence where the first term is 2 and the n plus 1 term is the n term plus 4, then what is the sum of the first 35 terms? Look here, the first term is already known, which is 2, but from an plus 1 is equals to an plus 4, we get that the common difference is 4. You know why here? When you put n is equals to 1 here, it becomes 2. Put n is equals to 1 here, it becomes 2. So here it becomes 1, a1 plus 4. So this implies the second term minus the first term is 4. Similarly, you can check that the difference between the third and the fourth is 4. So the common difference is 4. The common difference is 4. We have the first term. Therefore, it's very easy to calculate the sum of the first 35 terms. So the sum of the first 35 terms means, shortly we can write S35, which is given by the formula 35 over 2 into 2 times the first term. Here the first term is 2, plus 35 minus 1 times the common difference. So this is 35 over 2 into 4 plus, this is 34 times 4, 100. 34 times 4 is 136. Okay, this is 136. Okay, so this is 134. I mean 35 over 2 times 140. So this is 35 times 70, or you can make it 350 by 7. So the result is like this: 38. No, the result is 350 times 7. Okay, 7 times 0 is 0. 7 times 5 is 35. We have 3. 7 times 3 is 21. With 3, 24. So this product is 2450. Okay, so this is the answer for this problem is C. What is the sum of all multiples of 3 between 20 and 200? Here we are asked the sum of all multiples of 3 between 20 and 200. First of all, the first term, which is a multiple of 3 between these two numbers, is 21. The second term is 24. The third term is 27, and so on, and so on. The last term, which is a multiple of 3 between these two numbers, is 198. You can check that this number is a multiple of 3 using divisibility test. So if you use divisibility test, you can check that this is 198 is a number divisible by 3. So the question is finding the sum of all the multiples of 3. We just sum it up, all these things, but we don't need to list out all the terms, but we have to determine how much terms we have here. Okay, to know the number of terms, the last term, say an is 198. The first term is 21. The common difference is 3. So applying the nth term formula, an is equals to a1 plus n minus 1 times d, we can determine the value of n. So an is 198. The first term is 21 plus n minus 1 times the common difference is 3. So this is 198 minus 21 is equals to n times 3 is 3n. This is minus 3. So this becomes 177 is equals to 3n minus 3. This implies 177 plus 3 is equals to 3n. Now this is 180 is equals to 3n. Dividing both sides by 3, the value of n becomes 180 by 3, which is 60. Here, this 60 tells us there are 60 numbers which are a multiple of 3. So we are going to sum the all these multiples of 3. So S60 is equals to 60 over 2 into 2 times the first term plus 60 minus 1 times the common difference. Okay, so applying the formula for sum of arithmetic sequence, we get this much. This is 42 plus this is 59 times 3, but 59 times 3 is 177. So the sum of these two is 30 times 290. Okay, so multiply this thing. This is exactly the same as 2190 times 3. We can write like this. So multiply this thing. When we multiply this by 3, you will get 2190 by 3, 0, 7, we have 2, 5, 6. So this much. So the answer for this is 6,570 will be the answer. That means the sum of all multiples of 3 between 20 and 200 is 6,570. The last problem that I have here is the sum of the first 3 consecutive terms of an arithmetic sequence is 9. Okay, here in this sequence, it is assumed that all the terms are positive. We have this information. That means the sum of the first 3 terms, the sum of the first 3 consecutive terms is 9, which is given, and the other given information here is the sum of their squares is 35. The sum of their squares is 35. So what is the sum is n in terms of n? So the first term plus here, the first term plus the second term is a1 plus d. The third term is a1 plus 2d, which is 9. So this means 3a1 plus d plus 2d is 3d, which is equals to 9. Now this gives us, dividing both sides by 3, this gives us a1 plus d is 3. We have this thing, a1 plus 3 is, a1 plus d is 3. Now we can also observe this thing, a1 square plus a2 means a1 plus d square plus a3 means a1 plus 2d. Okay, a1 plus 2d, but for simplicity I want to write like this: the whole square is equals to 35. Here a1 means 3 minus d. So in place of here a1, I can write 3 minus d, the whole square, plus a1 plus d is already 3. It is 3. So 3 square plus here a1 plus d is 3. 3 plus d, the whole square, is equals to 35. So this implies 9 minus 6d plus d square. Okay, this is 3 minus d, plus 3 square is 9, plus 3 plus d, the whole square, means 9 plus 6d plus d square is equals to 35. Okay, so collecting like terms, we have 2d square plus 27 is equals to 35. This implies 2d square is equals to 35 minus 27, which is 8. 2d square is equals to 8 means d square is 4. This implies d is plus or minus 2, but since all the terms are positive, we reject the negative d value here. Okay, we reject the negative d value, so we take only d is equals to positive 2. Now we will use the nth term. Actually, here the first term is 3 minus d, which is 3 minus 2. The first term is 1. The common difference, look here, the first term a1 is 1, and the common difference here is 2. So use the nth term formula. Sn is equals to n over 2 into 2 times the first term plus n minus 1 times the common difference. So this can be written as n over 2 into 2 plus 2n minus 2. The result is n over 2 into 2n. So by 2 it becomes n times n, which is n squared. Therefore, the sum of the first nth term is n squared. So this is what it looks like. These are the questions from the past national examinations regarding arithmetic progression. So if you are new for my channel, don't forget to like, subscribe, and share.